Hi everyone, this is NNV Pondarangarao, working as an assistant professor in the Department of Freshman Engineering in St. Martin Engineering College. Today my session is the treatments of boiler feed water by ion exchange process. Okay, in this process first we have to know the boilers. So what is the use of boilers? In boilers used in different industries, maybe food processing industries, automobile industries, pharmaceutical industries, metallurgical industries. Okay, different you have to use in different industries. So what is the use of boilers? Boiler to convert the surface water and groundwater, groundwater into the steams. So during the process we have to use that one is the different types of boilers are used. So in this purpose we have to use that one is waters. So water mainly consists of different impurities. So impurities are dissolved salts. So that dissolved salts is nothing but hardness causing salts are there. Hardness causing salts are there. So what are the hardness causing salts present in surface water and groundwaters? So mainly that one is calcium bicarbonates, magnesium bicarbonates, calcium sulfate, magnesium sulfate. So a little bit that one calcium chloride and nitrates, magnesium chloride, nitrate, iron and magnesium salt, ammonium salts. So what is the chemical formula? The chemical formula, calcium carbonate chemical formula is calcium carbonate chemical formula is that one is CaHCO3. So this is a chemical formula for calcium bicarbonates, and chemical formula for magnesium bicarbonate MgHCO3 taken twice, and calcium sulfate CaSO4, and magnesium sulfate that one is MgSO4, and a little bit calcium chloride CaCl2, and calcium nitrate CaNO3 taken twice, magnesium chloride MgCl2, and magnesium nitrate MgNO3 taken twice, and iron and magnesium salt. Iron salt is nothing but Fe2O3 2H2O. So this is the chemical formula for iron compound. That one is next one is magnesium salt MnO2. Next one is aluminum components AlOH taken thrice, and a little bit magnesium hydroxides. So especially these are the salts present in waters. During the what is the boilers? The boiler convert that one is so water into the steams. In water, surface water, groundwater. So mainly consists of these are the salts are there. So what happened? So continuously, what happened? So that one is main one, that one is hardness. So based on the salt is nothing but cations and anions. So based on the presence of cations, hard water classified into two types. So carbonate hardness, non-carbonate hardness. The carbonate hardness, other name is nothing but temporary hardness. So that one is bicarbonates of calcium and magnesiums. So next one is permanent hardness causing salts, sulfates of calcium magnesiums, nitrates of calcium magnesiums, and chlorides of calcium magnesiums. So these are the different between temporary hardness causing salts and permanent hardness causing salts. So next one, what happens? So these are the salts. So mainly present in water. So during the boiling of water, what is the advantage of that one is boiler? The boiler surface water or groundwater convert into steams. So continuously, vigorously, we have to convert surface water into that one is steams. So the concentration of these hardness causing salts present in boiler, that one is increases. Day by day, the concentration that one is increases. The hardness causing salts sticking on the inner walls of the boilers. Some are that one is strong othering on inner walls of the boilers. Some are that one is loosely othering on inner walls of the boilers. So what is the main drawbacks? So what are that one is strong sticking of hardness causing salts? So that one is mainly consists of calcium chloride and calcium chlorides. So next one is calcium bicarbonate. These are the scale causing salts strongly othering on inner walls of the boilers. So remaining one, that one is chlorides, sulfates, nitrates of magnesiums. So due to strongly othering, what happens? So that one is the working capability of that one is boilers are decreases. During the conversion of that one is steams, the temperature difference is created. The inner side and outer side sometimes that one cracks are happens. That one is they have to require more consumption of fuels. So these are the disadvantages are there. To avoid these advantages, so water, first of all, you have to remove the total hardness causing salts. So how to remove the total hardness causing salts? So we have to implement it. That one is two methods are there. So one is the external treatment methods, other one is internal treatment methods. So external treatment method. So external treatments method, so mainly that one is, so what is the external treatments? The external treatments is going on, that one is outside the boilers. The internal treatments, that one is inside the boilers. So what is by, so external treatments, so this is a process. So removal of total hardness causing salts, or maybe that one is converted to total hardness of salts converted into that one is dissolved salts or soft salts. So by the outside implementation of outside process. But what is the internal treatments? So internal treatment, that one is inside the boilers. So what you have to do, that one is, so the conversion of scale forming salts converted into that one is sludge. So internally you have to add the chemicals. So example for, so external treatment is nothing but ion exchange process. Ion exchange process. So this is a external treatments. The internal treatments, so we have to add different reagents based on the adding of reagents. So different processes are there. First one is Calgon conditioning. First one is Calgon conditioning. Second one is phosphate conditioning. Conditioning is nothing but that one is a process. So third one is, that one is colloidal conditioning. So these are the different methods. We have to remove total hardness causing salts. The first of all I have to explain that one is ion exchangers. So what is ion exchangers? What is the structure of ion exchangers? How to synthesize ion exchangers? Ion exchange is nothing but exchanging of ions. So exchanging of ion is nothing but that one is anion, other one is cation. The anions and cations present in ion exchanger, that one is replaced with anions and cations present in dissolved salts. So that one is entirely you have to remove total hardness causing salts. Ion exchange is nothing but they have to take the ions and give the ions. So this is the process going on. So how to that one is synthesize ion exchange? Ion exchange is a cross-linked high molecular weight of organic compounds. So the functional group is attached to the high molecular weight of organic compound responsible for the ion exchangers. So what are the ion exchangers? Ion exchange is nothing but maybe cations or anions are exchanged by the another anions present in salt waters. How to mainly that one is ion exchange is extracted from the plants and animals. This is a ion exchangers. Ion exchange. This is a structure of, this is a compound. You have to see this is a compound structures. So this is in marketed name. Market name is nothing but, so that one is Dowex 10, Umberlite 100. So this is that one is act as a cations. So Dowex 10. Next one Umberlite 400. That one is act as a cations. And in market, so different ion exchanges are there. So based on the functional groups. So based on the functional group attached to the organic compounds, that one is polymers. It can be classified into two types. So one is cation exchange reagents, other one is anion exchange reagents. Cation exchange reagents. So these are the different types of structures. Cation exchange reagents. How to synthesize that one is cation exchange reagents. Cation exchange reagents, these are organic compounds. The complex organic compounds, that one is ion exchange reagent. Ion exchangers. Ion exchanges are two types. So one is cation exchange reagent, cation exchangers. Other one is anion exchangers. Cation exchange reagents. The cation exchange reagent, it is a acid functional group attached to the polymers. It is capable of exchanging of H plus ions with other cations present in waters. So that one is these H plus ions attached to the hydrogen attached to the attached to the polymers. This is a cation exchange reagent. Mari anion exchange reagents. So this is the alcohol group, basic components attached to the polymers. This is capable of exchanging of OH minus ions with anions present in hard waters. So this is the anion exchange reagents. So example, what is the example for the anion exchange reagent? Is nothing but sulfonate coal. So one is sulfonate coal. So the chemical formula is nothing but RSO3 H plus. So other one is R acid group functional groups are there. So other one R minus H plus, it is entirely denoted as RH. So this is a RH2, this is a representation for cation exchange reagent. An example for anion exchange reagents are quaternary ammonium salt. So what is the structures? R dash N R3OH, or maybe that one is ROH, otherwise it is denoted as, so that one is R dash OH. So these are the different between the cation exchange reagents and anion exchange reagents. Cation exchange reagents and anion exchange reagents. So these are the classification of cation exchange reagent and anion exchange reagents. So this is a polymers. In these polymers, they have to add with anion exchange reagents and cation exchange reagent. So next ones. So this is the chemical structures. The structure of cation exchange reagents. So this is a polymers. In that polymers, we have to attach that one is hydrogen ions. So this is a cation exchange reagents. So next one is, so this is the anion exchange reagents. So anion exchange reagent is nothing but, this is a polymer. In that place we have to attach with that one is OH groups. That one is the basic properties of that one is and any chemicals, that one is NH2. So this one is act as a anion exchange reagents. So what are the processes going on? And exchanging. So exchanging of ions, for examples, in surface waters, in lake waters, maybe groundwater consists of NaCls. So that one is absorbed by cations. NaCl, in NaCl, that one is sodium cation is absorbed on the surface of resins, and it can take that one is Na plus and gives H plus ions. The H plus ion present in that one is resins. And in anion exchange reagents, chloride is a anion. The chloride ion is absorbed on the surface of anion exchange reagents. It can give that one is OH minus ions, and H plus and OH minus ions so convert into waters. So this is a demineralized, so deionized waters. So what is the diagram for that one is ion exchange reagents? So this is a diagram for ion exchange reagents. So in the ion exchange reagent, two columns are there. The first column is consists of cation exchange reagents. In the second column, it is consists of anion exchange reagents. When water passes through that one is inlet, topmost sides. So what happens? That one is in between. So that one is cation exchange reagents are there. The cations, entire cations. What are the cations? So what are the cations? Are calcium and magnesiums. The calcium and magnesiums absorbed on the surface of cation exchange reagent. It can gives only anions. The anions and already cations are in cation exchange are replaced by the H plus ions. It can give the H plus ions and cation combined to form a acids. After filter water consists of acidic natures. The acidic nature of pumped into that one is another columns. The another column consists of that one is anion exchange reagents. In anion exchange reagent, the OH minus ions, the anions are absorbed on the surface of the anions, and it can give that one is OH minus ions. In previously, it can give H plus ions. In the second stage, it can give the OH minus ions, the H plus ions and OH minus ions combined to form a water. This water does not contain any hardness causing salts. This what is also called deionized process, impure waters. After what happens? So continuous process going on. Continuously the water consists of that one is cations absorbed on the surface of the cation exchange reagent and anion exchange reagents. Continuously that one is deactivated. But how to activate it? We have to use in left sides. So we have to passes through the HCl solutions. The HCl solutions, that one is the chlorides ions are replaced by that one is calciums. It can form that one is RH. Again that one is activated. Again in right sides, so we have to passes through that one is anion exchange reagent. That one is OH mains are replaced. It can form that one is ROH. That one continuously that one is regenerated. Again activated. So again activated. So what are the again activated? So what are the chemical reactions are there? First of all, I have to explain that one is the mechanisms. What type of mechanism is going on during the process? So entirely you have to remove that one is total hardness causing salts. Okay, in this process, so we have to remove that one is total hardness causing salts. So this is a ion exchange reagent. This is a video. This is ion exchange reagents. In this video, first of all, the reagent ready to exchange for that one is cations and anion present in water. First of all, this is activated states. So next one, that one is the ions. Ions are replaced in this process. First one, so in this cation reagent, the cations such as the calcium magnesiums, so that one is replaced. So calcium magnesium ions are replaced. They are replaced by the H plus ions and reduce the pH of the liquid. Entirely H plus ions are entirely calcium magnesium observed on the surface. In anion exchange reagents, the OH ions are replaced. Again the pH that one is increases. So these are the processes going on. So in anion exchange reagent and anion exchange, what happened? The continuous process going on, that one is deactivated. So over removal of H plus and OH minus ions. So this is exhausted. But how to that one is activated? How to activate it? How to regenerate it? That one is how to regenerate it by adding up that one is HCl. HCl solution is added to remove that one is previously that one is bind with calcium magnesium ions are removed. So this is a NaOH. That one is again that one is anion exchange. That one is so regenerated. So overloading of H plus ions or OH minus ion in anion exchange reagents and cation exchange reagents. So continuously this is that one is this is activated. Anion this is activated. That means anion exchange reagent activated. Cation exchange reagent that one is activated. Again we have to implement that one is purification of water. What type of mechanism is going on in cation exchange reagents? I have to explain that one is mechanism. So what type of mechanisms? So mechanism is nothing but I have to explain these mechanisms. First of all, it consists of different impurities. Impurities you have to remove in this process. Okay, in this process, first one, what is the mechanism? Mechanism in cation exchange. Cation exchange reagent RH plus. So that one is reacts with calcium cations. So cations, it can form that one is RCa2 plus, and it can give that one is 2H plus ions. First of all, 2H plus ions. So next RH plus, 2RH plus ions. So reacts with that one is magnesium cations. It can form that one is R2Mg2 plus. It can give 2H plus ions. That means H plus, it can be reacts with, for example, calcium bicarbonate. Calcium bicarbonate is there in that one is a dissolved salts. It can be removed R2Ca2 plus. It can form that one is H2 carbonic acids. So carbonic acid is formed. Carbonic filter water consists of carbonic acid. So next one, 2RH plus. 2RH plus reacts with that one is calcium sulfate. It can form that one is R2Ca2 plus and gives rise to H2SO4. Next one, R2H2SO4, H2SO4. So next 2RH plus, 2RH plus, so reacts with calcium chlorides. So calcium chlorides, so it can form R2Ca2 plus and 2HCl, 2HCls. So next one 2RH plus, so reacts with calcium nitrate, calcium nitrates. So it can form that one is R2Ca2 plus HNO3s, HNO3s. Previously already explained. So these after filter water consists of acids, acid dissolved in water. So what are the mechanism is going on in cation exchange reagents? In cation exchange reagents, ROH, R dash ROH minus ions. So reacts with that one is, so bicarbonates. So bicarbonates, it can form that one is bicarbonate, it can form RCO3 2 minus R2 and gives rise to 2OH minus ions and 2ROH minus ions, OH minus ions. So reacts with sulfate SO4 2 minus, it can form R2SO4 2 minus and gives rise to 2OH minus ions. And the next one is 2ROH minus ions. So reacts with that one is chlorides, it can form that one is RCl and 2OH minus ions. So entirely it can give, so that one is OH minus ions. So what are the process going on? So what are the processes going on? First of all, 2ROH minus ions, 2ROH minus ions, so reacts with bicarbonates, carbonic acids, it can be formed, that one is RCO3 2 minus plus H2O plus H2O, so that one is water. So we have to get that one is demineralized waters. Again ROH minus ions reacts with that one is H2SO4, it can form that one is RSO4 2 minus, finally it can give that one is waters. Again ROH minus ions, so reacts with that one is HCl, it can give that one is RCl plus H2O. For example, ROH minus ions, so reacts with that one is chlorides, maybe other components, all anions are removed. Finally we get that one is deionized demineral waters. So deionized demineral water is nothing but that water does not contain any hardness causing salts. Again, how to regenerate? This process, how to regenerate? So regenerated purpose we have to use that one is one of the solution, two solutions are there in cation exchange reagents. So we have to use, in cation exchange reagents we have to use, so mainly that one is HCl solutions in cation exchange reagents. So we have to use that one is we have to use NaO solutions. So these are the processes going on. Again that one is activated. These are entirely you have to remove that one is hardness causing salts. Entirely you have to remove that one is hardness causing salts. So the process going on, if you have to use this process, entirely you have to remove that one is hardness causing salts. So these are the processes going on in ion exchange process. So okay, your diagrams, this is the diagrams, these are the reactions. So reaction is going on. So this is a cation exchange reagent reactions. So these are the anion exchange reactions. These are the reagents. So regenerated means H plus ions, so belongs to the H plus ions. So H plus ion RH, that one is again activated. They can give that one is calcium. So the calcium may be calcium chloride, calcium sulfate, calcium nitrate. This is washed out. That one is another way. So next one is anion exchange reagents. Anion exchange reagents, that one is NaOH, the OH minus ions. So reacts with that one is after filtering of that one cation exchange reagents. So entirely you have to remove that one is acids, HCl, carbonic acids, sulfuric acids. Again that one is, these are washed out. Finally you have to get activated reagents. So what are the activated reagents? That one is cation exchange reagents and anion exchange reagents. These are the activated. So what is the advantage? So what is the advantage of, these are the these are the exchange reagents. That one is cost effective. So one is cost effective, reusable and easily collectible, low maintenance techniques. Other one, quick separations. So these are the advantage techniques. So these are the advantage techniques in ion exchange process. So first one is internal treatment. Next one is internal treatments. Internal treatments is nothing but, so we have to add that one is chemical in boilers. So in this process, first one you have to use that one is Calgon conditioning. The Calgon conditioning, which chemical you have to use, that one is sodium hexametaphosphate. Sodium hexametaphosphate. So these are the complex compound. We have to remove mainly scale causing salts. Scale causing salts, so observed on the surface of that one is sodium hexametaphosphate. It can be removed. That one is converted into sludge. So these are the calcium sulfate. Calcium sulfate is scale forming salts. So it can be removed. That one is dissolved. It can form, that one is calcium hexametaphosphate. These are the Calgon conditioning. This is the Calgon conditioning. So next one is phosphate conditioning. In this phosphate conditionings, so you have to use sodium phosphates, trisodium phosphates. Based on the alkalinity of waters. Alkalinity of waters, we have to use 3 types of sodium phosphates. So one is trisodium phosphate, second one is disodium phosphate, third one is monosodium phosphates. So trisodium phosphate you have to use when the water is, that one is alkalinity is very low. So next one is disodium phosphate, when the water is alkalinity is, that one is sufficient. Monosodium phosphate, when that one is that compound consists of, that one is high alkalinities. Based on the that one is nature of waters, we have to add 3 chemicals. So next one is phosphate conditioning. The phosphate conditioning. So this is a Calgon conditioning. Calgon conditioning. First one is Calgon conditioning. So next one you have to use, that one is colloidal conditioning. The colloidal conditioning you have to use, that one is organic compounds. The organic compound is nothing but agar-agar gels, starch, kerosins and tannins. These are the substance observed on the scale forming salts. So that one is, after forming, it can convert into non-othering surface, non-sticking surfaces, easily removed by using of excess of waters. So that one is, so internal treatment methods. In the internal treatment methods, we have to use that one is 3 process. The first one is the Calgon conditioning, second one is phosphate conditioning, third one is colloidal conditioning. These are the external treatments and internal treatments. Okay. External treatments and internal treatments. And next one is even some Arab countries, industries, you have to don't use that one is sea waters. So that way, that purification is also very important. So that one is salinity of waters. In that purpose, so mainly water can 90% of sea waters, maximum 90% of sea waters. So remaining, that one is 2% of fresh waters. 98% out of 87%, that one is ice caps. Remaining is river water and remaining river water and lake waters. Okay, lake waters. So that one, implementation of desalination process. Desalination, nothing but you have to remove the salt from sea waters. So in the purpose, we have to use, that one is, so one of the method is nothing but, that one is the reverse osmosis process. So reverse osmosis is nothing but the solvent is moving from low concentration to high concentrations. But reverse osmosis, the solvent is moving from high concentration to lower concentration. This purpose, so we have to apply osmotic pressures. So during the process, what happens? So entirely during the process, what happened? In this process, you have to use this membrane to the membranes. So on the surface, reattained total dissolved salt, you have to get, that one is, so demineralized and pure waters. So this water is used mainly, that one is, so industries. So that is the main advantage. Okay, that is the main advantage. These are the by using a implementation of this process, so that water you have to use, you have to save protect that one is boilers. The lifespan of boiler, that one is increases. So these are the advantage. These are the advanced technique. We have to use external methods or internal methods, or maybe that one is a reverse osmosis process, total entire process, that one is removed. So these are the treatments of feed water by external treatments and internal treatments. Okay, entire process is going on. So these are the advantages mainly using. So we have to protect the boilers. Okay, these are the main advantage. This is the topic we have discussed today. Thank you very much.